Hi, my name is Roger. I have been fooling around with vacuum tubes since I was about 12 years old, and they're really very easy to work with. I think that people make this far more difficult than it is, and I want to show you how simple it is to make a single stage vacuum tube amplifier. So first I'm going to draw it, and then later I have parts over here, and I will place the parts on the schematics so you can see where they go. Now in a single stage amplifier, first we can draw the tube, and I'm putting in a couple resistors as I go just because I like to work from top to bottom. And here we are. So here's the symbol for the vacuum tube. It has a plate, which is a straight line at the top, has a grid, which is a dashed line below the plate, and it has a cathode that's kind of a L-shaped with a little hook on the end at the bottom of the tube. The electrons, well, they actually flow from the cathode up to the plate, but we like to think about currents flowing from positive to negative, just like water going from high to low. So we don't really care about the electrons. We just know they go the other way. Up on this end, we need to put a B+, and down here we have a heater. That's the part that glows. It's the only part that should glow. And in a preamp tube, don't expect it to glow really bright. You might have to be in a darkened room to actually see it. And it glows a reddish-orange color. And its job is to heat the cathode, and that's why we draw it under the cathode. And so the electrons can basically be boiled off the cathode and then be attracted to the plate. Now in a vacuum tube amplifier, you need two sources of power. You need one source of power to run the heater, and that could come from a transformer, which we'll draw down here, or it could come from a 6-volt battery. A lot of people use DC on heaters because it will give you less hum in a very sensitive circuit, but in many circuits you can use AC on the heaters, which is a bit more convenient. Later we'll talk about how you would make a DC power supply to run the heater. For now, let's just stay with the simple single stage. Now the parts here, besides the vacuum tube, you need to supply the circuit with some high voltage that's also DC, and this B+ is typically between 200 and 400 volts. If you have more B+, you can create a larger signal. If you have less, a smaller signal. But in any event, in a preamp, we're generally trying to only create 5 or 10 volts of signal, and 200 volts is plenty to do that. To create this signal, we start with an input, which we're going to put directly onto the grid. And if your input was, say, a guitar pickup, you need some sort of DC return path to ground, so you could put a resistor here like a 1 meg. Very high resistance, because we only need that to return what small currents from the electrons falling on the grid, just to return those to ground. But if you realize if you put a guitar pickup out here, it's a much lower impedance, and the 1 meg could be eliminated. Again, it's not a big deal. You might put it there just in case someday someone plugs in something with a capacitor in series, and then you'll need that resistor. If you don't have the resistor, the amplifier will actually cut itself off. Now, once we've got the signal into the tube, we need to take the signal out of the tube. Hopefully the signal will be a lot bigger. That's what we want. Now to bring the signal out, we can't take it directly off the plate because there's about 100 volts on the plate. By the way, the plate voltage is usually about half of the B+. That's always a good place to start. So somehow we have to get rid of this 100 volts of DC, which we don't want, and just get our signal out here, our 1 or 5 or 10 volt signal that we want. And there we use a coupling capacitor. And that could typically be a 1 microfarad. A little larger will make the system go to lower frequencies, and a little smaller will not let it go as low. This capacitor actually determines the low frequency response of the amplifier. Now we also might want to put a resistor out here, because if we don't, we need some place to bleed that current from the capacitor. Actually, the capacitor needs a path to charge, and we don't particularly want it to charge up through whatever we're putting out here on the outside. That resistor might typically be a meg, or it might be 100K. If it gets too small, it will load this stage too much and you'll lose some gain. Now, how do we know about the gain of this stage, by the way? Well, I happen to represent this company called Preamp Tubes, And here's one of our tubes, and we actually measure the gain of the tube, and this is a 12AX7. And the 12AX7, by the way, has two triodes in one glass envelope, and the triodes are not exactly the same. They're supposed to be the same, but we know they're not exactly the same. And here we see that one triode has a gain of 49 and one has a gain of 50. So we could say these are fairly well matched for gain, and in another talk we'll talk about matching. We also measure the noise, and we measure the microphonics, and this is a very low noise and very low microphonic tube. These, by the way, are available at tubeaudiostore.com. So we'll take a look at that tube in a moment. Well, we'll take it out of the box so you can have a picture and have a look at it. This happens to be one of our new old stock tubes, and this is an Amperex Bugle Boy. And you can see possibly the little picture of the tube blowing a bugle. That's why it's called a Bugle Boy. These were made by Amperex in the 1950s and further on in Europe. This was actually made in Holland. And these are considered excellent tubes. They tend to be low noise and low microphonic because they were made for audio use where noise is very important. We'll take a look at that in a moment. So there was one more part of this circuit we need to look at, and that is the cathode resistor. Now the cathode resistor is really important because it sets the bias of the tube. Across this resistor, a small voltage, approximately 2 volts for a 12AX7, 2 to 3 volts, is developed across this resistor by the current flowing down through the tube. This is called self-biasing. The other way to bias the tube is actually to put a negative voltage on the grid, but that's more difficult and very rarely done. Another advantage of this self-bias, it's also called cathode bias, is that if you put different tubes in here, it tends to even out the differences in the tubes as far as the plate voltage is concerned. And the plate voltage is rather important to amplifiers because it determines the distortion, and especially in a guitar amplifier where you want distortion, this voltage will determine the point at which distortion occurs. And if you want to, you can make this voltage quite low by making this resistor higher and get your distortion earlier at a lower level. These are the things I encourage you to try. Now another thing, that, by the way, though, is if we leave this cathode resistor the way it is, we're going to lower the gain of the amplifier quite a bit. So typically there's a capacitor connected in parallel with this, and this is usually an electrolytic capacitor, unlike this capacitor, which is a film capacitor. And we use an electrolytic here because whereas this capacitor might be only 1 microfarad, this capacitor is a very large capacitor, like maybe 470 microfarads. If we got that capacitor in the same kind of mylar, it would be as big as this piece of paper and very expensive, and where would you put it anyway? It is perfectly acceptable and has been done forever to put a electrolytic capacitor here. Now I'm going to turn this circuit around so you can have a little better look at it, and I'm going to show you the parts and where they go. So we could, if you were wiring this up, of course, the tube is the last thing you put in, and the first thing you probably put in is the tube socket. So here is a 9-pin tube socket. I particularly like this kind of socket because it has some unusual features that you don't always see. One is these 4 rings around the edge, which are connected to the saddle, which is connected to your chassis, and if everything is clean and screwed down tight, these become very convenient grounds. This will save you having a terminal strip or trying to find some way to screw grounded things down or putting a solder lug here. These are very convenient. And the center post is convenient also because you can use that for anything you want. I tend to use it for my B+, because it's right close to where I want it to be and it's there. And again, this allows me to make amplifiers without using terminal strips. It just saves you the time and expense of doing that. Now also keep in mind that 12AX7 is a twin triode, so we're only going to use half of it in this circuit. In a later talk, we'll use the other half and make a 2-stage amplifier. There are times, by the way, when people take a 12AX7 and wire the 2 sections in parallel to make sort of a stronger tube, but frankly it doesn't make that much difference, so I don't recommend bothering with that. Now the pins on this socket are numbered from 1 to 9, and in most sockets you can see little numbers, but also it's been conveniently arranged so that when you look from the bottom of the socket, you start clockwise from the gap, and that's pin number 1, and you just go in order 2, 3, 4, 5, and so forth. Now 4 and 5, these two over here, are always the heater. And on all these 12-volt tubes, these 2 pins are always the heater. The first 3 pins are one section, and the second 3 pins after the heater are the other section. And the last pin is sometimes a shield between the sections, but in the 12 series tubes, like the 12AX7 and the 12AU7, this is actually a center tap for the heater that allows you to run this tube off of 6 volts if you want to. Or it also allows you to run just one half of the tube if you want to. But generally we run both halves, and 12 or 6 you'll find just as many uses of 12 as you will in 6 if you looked at a bunch of different amplifiers. Now we're going to place, if we were going to make this unit physically, which I think is the hardest part people have, is going from a schematic to the actual physical layout. Now you could draw a picture, you could draw this, and you could draw the capacitors and everything, but then you're just fooling with you. You have to see how big they are and so forth. I just take a piece of metal that's about the right size to hold these parts, and I just build it right from the schematic. So let me show you how you would do that. So if you were to place the tube socket here, and if we were to use, well, we could use either these 3 pins or those 3 pins, and you can look up in any tube manual the pin outs, but I'll tell you that pin 1 is the plate, 2 is the grid, and then 3 is the cathode. And when we come past the filament, it's in the same order again: plate, grid, cathode. So 1, 2, and 3 are plate, grid, and cathode, and then 6, 7, and 8 are plate, grid, and cathode for the other side. Now I'm not going to show you the filament supply or the power supply yet. We'll do that another time. Right now we're just interested in the amplifying circuit. So we know that there will be some power supply to this heater, so we can just leave 4 and 5 alone for now, and we'll connect them up later. We're mainly concerned with the audio part of the circuit. Now here's some typical parts. Here is a typical plate resistor. Now this is about a 1 or 2 watt resistor. Often we use something of a little of that wattage because this resistor can get fairly hot depending on how much current the tube is drawing. You could certainly get away with a half watt resistor in this case, and this is 120K. Typically 100K to 220K is very typical for a 12AX7. So this resistor is literally just going to go between pin 6 and your B+. Now I like to do this. I just sort of bend this over, and I'd cut this lead off, and I'd stick that in there and connect from there, solder from there to pin 6, and now I have my plate load resistor connected. It's convenient to use this thing in the center because if we do the other half of the tube, we'll use that again for the other plate load resistor. So we'll put that there. Then we have to have a cathode resistor. Now, a cathode resistor could be as small as a 1/4 watt, or if you like half watt resistors, here's a half watt. And you can look at the relative size of these 3 resistors, and you can see 1/4 watt, half watt, and 1 watt. So we'll put our cathode resistor here, and it's going to go to ground. Well, we have ground right here. In fact, we have 4 choices of ground. Isn't that convenient? So we can take this resistor, and we can connect it between, see, that would be the last pin 8 over here, and we can just connect it right there between 8 and that little ground lug. Then we have to put a capacitor in parallel with that, and here's our capacitor. This is a 470 microfarad 16 volt capacitor, and it would go from the same 2 terminals. Keep in mind this has polarity. Now resistors don't, but this has a negative side, and it's marked. The negative side is going to go to the ground, and the positive side will go to pin 8. So those pieces go there. Now we don't have much left. The input can go directly to the grid. And if you want this 1 meg resistor, it can go directly from the grid, which is over here, pin 7. That 1 meg can go from 7 to another ground lug, or the same ground lug. They're all the same. And then you can take the input directly into pin 7. Some people would put a resistor in series with pin 7, and you can do that. With a 12AX7, it's not necessary. With higher gain tubes, it can be helpful. Now we have our coupling capacitor. Now if you are coupling to something of low impedance, you might want something rather big. This is a 4 microfarad 400 volt capacitor. Pretty big. I think that's about it for now. Thank you for listening.